All right, guys, this is Monday. So we're starting out with 7 more than the product of 6 and 9. So last week we talked about how anytime we see two numbers in a sentence like this between the word and, that we are to group them together. We are to put these two friends in the same room, which by that I mean in parentheses. So we're going to put these two numbers in the parentheses. And it says the product of 7 and 9, and we know product is an answer to a multiplication problem, so we're going to put a multiplication symbol there. And it says 7 more. So 7 more. So whatever we get has to be 7 more than this product. So we start off with the parentheses. 6 times 9, that's 54. I have nowhere to write that because I did not plan properly. So 6 times 9, that's 54, plus 7. And so if you have a hard time with this type of thing, you can always stack it up. The standard algorithm of addition, 7 plus 4, that would be 11. 6. So the answer to that would be 61. All right, number 2. Move this up some. So we have 2 tenths times 3 tenths, which means we are multiplying a decimal by a decimal. So we're going to model one up and down and the other side to side, starting with the first factor, 2 tenths from top to bottom, by or times 3 tenths, which would be, so we're doing side to side. Of course, within the model, the answer is going to be this part here, where the two colors touch. And so if we really, really take a good look at that, we are looking at 6 hundredths, right? Because that's 1, 2, 3, 4, 5, 6 hundredth blocks, if we are remembering that this is a 100th block. So when we multiply decimals, we multiply like we're looking at whole numbers. Circle, circle, move it, move it. And what do we do with this empty space? Fill it in with a 0, which that reads 6 hundredths. Number 3, we did this last week. We are subtracting fractions with unlike denominators. So step 1 is to get the denominators to match. And we can do this in an area model. So this very first one, we are going to model 1/2, right? And then for the second one, we are going to model going the opposite way, 1/4. And I'm modeling 1/4 by dividing this into 4 parts and shading 1. Then we come back and we cross over. So if I divided this one up and down, and I'm going to come to the opposite and do the same thing. If I divided the second one across side to side in 4 parts, I'm going to do the exact same thing. So I'm further subdividing the models, right? So then 1/2 becomes 1, 2, 3, 4, numerator 4, shaded parts of 8. And 1/4 becomes 2 shaded parts of 8. And then we simply subtract, remembering that the denominator stays the same, and 4 minus 2 is 2. And then we would simplify that, and that would become 1/4, and we'll talk about that more. Number 4, which number is equal to 10 to the 3rd power? So we are looking for 1 with 1, 2, 3 zeros. Number 5, we are converting meters to centimeters. So we are going from a large unit to a small unit. So how many centimeters are in 1 meter? Centi means 100. So there are 100 centimeters in 1 meter. So to figure out how many centimeters are going to be in 2 meters, you will multiply that by the exchange rate, which is going to be 100. So it'd be 200 centimeters. Here we are going from big to, we're going from small to big, which means we are going to divide. So we're starting out with 3 3,000 grams. How many grams are inside of 1 kilogram? Well, kilo means 1,000, a big thousand. 1,000 wholes, right? So we would be dividing 3,000 by 1,000. And we learned in topic 4 that when we are dividing, in topic 5, so when we're dividing by multiple of 10, we can start canceling out zeros on both sides of the division sign, and then we would just divide the non-zero digits. So 3 divided by 1 is going to be 3. So there are 3 kilograms in 3,000 grams.